In this lesson, we'll be looking at how to solve systems of two linear equations with two unknowns using the substitution method. Now, a system of linear equations is just a set of more than one equation, so in this case we have two equations, and when we say two unknowns, we just mean that both of those equations have two variables. So in this case, our two variables are x and y. Now, in order to solve this system of equations, what we want to do is find an x and a y that solve both of these equations at the same time. Now, the way that we're going to do that is using the substitution method, and the first thing that we want to do is we want to choose one of the two equations and one of the two variables, and we want to get that variable by itself in that equation. So we're going to choose the second equation, and we're going to get y by itself. So the first thing that we want to do is subtract 2x to the other side. So on the left-hand side, that's going to leave us with negative y, and on the right, we'll have 4 minus 2x. Now we can go ahead and multiply by negative 1 on both sides, and that will leave us with y equals negative 4 plus 2x. Now that we've written y in terms of x, what we want to do is we want to plug that back in for y in the other equation. We don't want to plug this into the equation that we got it from, because what would happen is things will just cancel down, and it'll cancel down to 4 equals 4, which is true, but it's not very helpful. When we plug it into the other equation, what we'll be able to do is solve for x. So here we'll have 6x plus 5, and then instead of y, we're going to put in negative 4 plus 2x. Notice how now we've completely gotten rid of y, and so this is just a normal equation with one variable that we're going to solve. So the first thing that we need to do is get rid of the parentheses, and so we'll distribute. We have 5 times negative 4, that will be minus 20, and we have 5 times 2x, which will give us 10x, and that's still equal to negative 4. Now on the left-hand side, we want to combine like terms, so we'll take the 6x and the 10x and we'll add them together to get 16x. We still have the minus 20, and then that's equal to negative 4. Now we want to get the x term by itself, and so we'll add 20 to both sides. On the left-hand side, those 20s will cancel, so we'll have 16x equals negative 4 plus 20, which is 16. Now we want to get x by itself, so we'll divide by 16, which gives us x equals 1. So now we've solved for one of the two variables. The next step is going to be to solve for y. We want to get both x and y for our solution. The way that we can get y is we can plug x back into either one of our first equations. So let's go ahead and plug it into the second equation. We'll have 2 times 1 minus y equals 4. Now this equation only has y in it, so we can solve for y. We'll rewrite this as 2 minus y equals 4. We want to get y by itself, so we'll subtract 2 from both sides. That leaves us with negative y equals 4 minus 2, which is 2. Now we can multiply both sides by negative 1, and that will leave us with y equals negative 2. So our final solution to this system of two equations, two unknowns, is x equals 1 and y equals negative 2. Now it just happened to turn out in this problem that our x and our y values were really nice numbers. They were both integers or whole numbers. A lot of the times when you're doing these problems, your answers aren't going to turn out to be these nice integers. A lot of times they'll be fractions. So let's go ahead and do an example of a problem where you end up with some pretty nasty fractions. Here we have the system of two equations, 3x plus 7y equals 11, and negative 2x plus 6y equals 5. We're going to go through the same method that we did before. It'll just be that this time we'll have some fractions to deal with. But it's good to get practice doing these problems with fractions, because fractions are going to come up throughout all the math classes that you have from now on, and they'll come up on your test, so you need to practice them even though they can be kind of hard at times. Here we go. We're going to choose the second equation again, and we're going to get y by itself. To do that, we'll add add 2x to both sides. On the left-hand side, the negative 2x and the positive 2x will cancel, leaving us with 6y. And on the right, we have 5 plus 2x. Now we want to get y by itself, and so we'll divide by 6 on both sides. On the right-hand side, that means we need to divide each piece by 6. So we have 5/6 plus 2x over 6. So on the left-hand side, that leaves us with y, and on the right, we have 5/6 plus 2/6, which is 1/3 x. Now that we've solved for y in terms of x, we want to plug that back into the other equation, which is the first equation. So let's go ahead and do that. Here we'll have 3x plus 7, and now instead of y, we're going to put in 5/6 plus 1/3 x. And that's still equal to 11. Now we want to get rid of the parentheses, and so we're going to distribute. We'll get 7 times 5/6. So here we go with the fractions. We'll have 35/6, and then 7 times 1/3, which is going to be 7/3 times x. On the right, we still have 11. Now we want to combine the like terms on the left-hand side. Let's go ahead and make a little fraction corner down at the bottom. To combine these like terms, we want to add 3x plus 7/3 x. So we need to figure out what 3 plus 7/3 is. Well, we can rewrite 3 as 9/3 plus 7/3. Now we do this to get the denominator the same in each fraction. Once we have the denominators the same, remember we can just add the numerators. So we have 9 plus 7 equals 16, and we'll have that over 3. So back to our equation, we have 16/3 x plus 35/6, and that's still equal to 11. Now we want to get the x term by itself, so we'll subtract. Oh, actually, let's do a little trick here. So I don't really like to work with fractions when I don't have to. Here we have a fraction with a 3 on the bottom, and we have a fraction with a 6 on the bottom. Since 6 is a multiple of 3, if we just multiply everything by 6 on both sides, what's going to happen is that we will clear all of the denominators. In other words, we'll get rid of all the fractions and we'll end up with all whole numbers. So let's do that. The first thing we want to do is take 6 times 16/3. Well, 6 divided by 3 is 2, and so this is the same as 2 times 16, which is 32. So we have 32x. And then we'll take 6 times 35/6. Well, of course, the 6's just cancel, and that leaves us with plus 35. And on the right-hand side, we have 11 times 6, which we know is 66. See how that got rid of all the fractions for us? I love it when I can get rid of the fractions. Now, we want to get the x term by itself, so we're going to subtract 35 from both sides. Those 35's will cancel, so on the left we're left with 32x. And on the right we have 66 minus 35, which is 31. Now we want to get x by itself, so we're going to divide by 32 on both sides, which leaves us with x equals 31 over 32. Now we've solved for x and we want to solve for y. So remember, we can take this x value and we can plug it into either one of our original equations to solve for y. Let's go ahead and plug it into the second equation. So we'll have negative 2, and in the place of x we're going to plug in 31 over 32, and then we have plus 6y equals 5. Now negative 2 times 31 over 32 is negative 31 over 16 plus 6y, and that still equals 5. Now we want to add 31 over 16 to both sides. On the left-hand side, those will cancel, leaving us with 6y, and on the right, we need to figure out what 5 plus 31 over 16 is. So let's go back down to our fraction corner. 5 plus 31 over 16. Now we need to rewrite 5 so that it has a denominator of 16. 5 times 16 is 80, so we're going to get 80 over 16 for 5, plus 31 over 16. Now we'll add 80 and 31, which gives us 111 over 16. So we'll come back up to our equation. That gives us 6y equals 111 over 16. Now we want to divide both sides by 6. On the left-hand side, we'll divide by 6. On the right, multiplying by 1/6 is the same as dividing by 6. Now let's go back down to our fraction corner and compute 111 over 16 times 1/6. Well, if we rewrite this, 111 is 37 times 3, and that's over 16. And 1/6 can be written as 2 times 3. We can cancel those two 3's. On the top we're left with 37, and on the bottom we have 16 times 2, which leaves us with 32 in the denominator. So we have y equals 37 over 32. I told you the fractions would be messy on this one.